Okay, so today's lesson is kind of
Oh my Lord.
the inverse of yesterday's. We're going to undo it. Today I'm going to give you zeros, and you're going to find a polynomial function. Now, it's not the only one, because we could vertically stretch or compress this and have multiple polynomial functions. We could have multiplicity at the roots and have multiple polynomial functions. So we're just going to come up with one that works. All right, so if you're given the zeros of the function are 0, -1, and 2, how would you write the complete linear factorization? Well, we start off doing x minus the zeros, right? So x minus 0, x minus -1, x minus 2. Well, of course, we're beyond writing x minus 0, so you would just make this an x. And you would make this x plus 1 and make that x minus 2. Now, this is interesting because this is both, like if we had started with standard form, this would be both the complete linear factorization and factored over the set of integers. It would be both. Now, how would we continue going backwards to get it into standard form? You'd keep multiplying. Now, I choose to leave a monomial to the end. You don't have to, but this is my choice. So I start with the binomials and I pair them up and I start multiplying. So x times x is x squared. And then I've got negative 2x and positive 1x. Negative 2 plus 1 is negative x. And then 1 times negative 2 is negative 2.
And that's where you got the from.
Okay? So all I did was multiply these two factors. Yes, sir? You still have to distribute the x. Correct. So, to be in standard form, which I'll put right here, we must distribute that monomial now. So it just takes everything up a degree. And that is standard form. Good. Good. That's it. So do you see how we're just kind of undoing what we did yesterday?
Yeah.
All right. I only have 3 examples, so we have 2 to go. Let's go. All right. So 5/2 and plus or minus root 3. Okay. So if you were taught old school like I was taught when you have a factor and you set it equal to 0, every time you solve, to move b over, it becomes the opposite. And every time you solve, this number right here is what you divide by. So anytime I had a factor, I would just go straight from this to this. So if I'm going backwards, the opposite of this goes here, and this goes here. Now, if that makes sense to you, do it that way. But if it doesn't, you're in luck. There's another method. So my first 0 is 5/2. So to find its factor, I just undo it. So to undo it, I would multiply by 2 and get 2x equals 5. And then subtract 5. And I would get 2x minus 5 equals 0. Now, do you see that my shortcut would have worked? The opposite of this goes here, and this gets multiplied by x. Pick your method. Okay? Now, this one is not a fraction. So when they're not a fraction, it's pretty easy. Just do x minus that. Well, I just did the positive one. Now let's do the negative one. X minus a negative becomes positive. So this line, if I had started with standard form and I was working my way to the zeros, this line is what we would call the linear factorization. Because it's every single one of these are linear factors. Now, that is not factored over the set of integers though, because square root of 3 is not an integer, is it? No. The next thing that you do, whenever you have factors that are identical except the signs, you want to start by multiplying those. because very nice things happen every time. It's like multiplying conjugates. Watch. X times x, x squared. Positive x root 3, negative x root 3. Yes, they cancel. So the outer terms and the inner terms are going to cancel. Every time we just have opposite signs. And then I do negative root 3 times positive root 3 is negative root 9. What's the square root of 9, guys?
Negative 3.
Negative 3, yeah. So it's x squared minus 3. So the product of those two binomials is x squared minus 3. So this is what we would call the completely factored over the set of integer form. See how we're kind of going backwards from what we just did? And then to go standard form, I'm going to multiply this in the order that will take me from greatest degree to lowest degree, because then I don't have to rewrite it. So I'm going to start with these two, because that makes a cube. And then I'm going to do a squared. And then I'm going to do the linear. And I'm going to round it out with the constant. And that is standard form. All right, last example. Okay. This is a positive 4i. There's an interesting thing about imaginaries. They do not exist alone. Because to get an imaginary number, we took a square root of a negative. Right? And when you take a square root of a negative, don't you get a positive and a negative? So even though positive 4i is the only one listed here, it must have negative 4i as a buddy. It has to. It does not exist by itself. All right, so those are easy. X minus 4i, x plus 4i. Okay, you can either use the shortcut, which says the opposite of the numerator goes here, and the denominator goes here. Or you could take this, set it equal to x, and then force it back to 0. So what do I mean by that? Take 2/3, set it equal to x, and then rewrite it as a 0. So times 3 minus the 2. Do you see we get the same thing? Okay. Always start with the opposites. In this case, conjugates. So, oh, hold on. I forgot my eye. Y'all noticed that. Good job. Okay, so what's going to happen to the outer and inner? Every time, they're going to cancel. Anytime I multiply opposites like this. So this becomes x squared close. It's minus 16i squared. So it is going to be plus, but we have to multiply those 4s. So it ends up making plus 16. And then the other one. So this is completely factored over the set of integers, if I had started with this line. Now to get this line, we just multiply these two. So I'm going to go with my cubic term first, because that's my highest degree. Then I'm going to go with my squared. I'll do the linear term next, and end it with the constant. And that's all there is to it. Okay, so the little half sheet is your homework assignment. It's where you're given the zeros and you're asked to write the different forms.